In this video, we're going to look at composite functions, specifically on forming composite functions, and we're still going to be paying attention to any restrictions we need to make on the domain. Let's begin by defining what exactly we mean by the composition of functions. The composition of the function f with the function g, denoted f composed with g, and is defined by the equation f composed with g of x is f of g of x. The domain f composed with g is the set of all x such that x is in the domain of g and g of x is in the domain of f. Notice what this is saying. I'm going to substitute x into the function g. When I get that answer, I plug that answer into function f. This is why the domain is any x that's got to be in g, because if it's not, I can't do g of x. And then that value, g of x, has got to be in the domain of f, or I can't take f of g of x. It may be a little clearer to see it through an example than through the definition. So here's an example given two polynomial functions. Now, choosing polynomials is easy because I know the domain is all real numbers. So I know that I'm going to be able to substitute anything I want to in for x and g. I'm going to start with g. And I'll be able to substitute anything I want to in for g. I'm going to get a real number for an answer, and since I'm going to get a real number for an answer, I can take it and plug it into f. So there's not going to be any restrictions on my domain here. My domain is going to remain the set of all real numbers. But to do the composition, f composed with g of x is to say f of g of x. Now if you'll notice, what's in this parentheses is what's taken the place of x. So I'm going to substitute the function g of x in the place of x for f. F was 5 times x, so it's going to be 5 times g of x, which g of x is 2x squared minus x minus 1, plus 6. Notice, five x plus 6. 5, my x, plus 6. I am simply substituting the g of x function into f. Then all I have to do is simplify. So I'm going to distribute the 5 through. That's 10x squared minus 5x minus 5. But then there's that plus 6. So then I'm going to collect like terms, and f composed with g to put it back in their original one, and that is not fog, that O is up above the line. F composed with g of x is 10x squared minus 5x plus 6, with the domain being the set of all real numbers. Not as difficult as it looks, but it may take a little getting used to. Now, because this can get kind of sticky, I want to do a few more examples. Let's do one where we have a radical function for f and a polynomial for g. Because it's a polynomial on g, I know the domain is going to be all real numbers, but I am going to have a restriction on my domain here. You can't take an even root of a negative number and stay real, so I'm going to say that that's got to stay greater than or equal to 0. So 2x has got to always be greater than or equal to 1, which means x has got to be greater than or equal to 1/2. Now, here's the deal. It's not x I'm concerned with, because when I take the composition, it's g of x, the value of g, that gets plugged in. So in this case, instead of x being greater than 1/2, I want g of x to be greater than 1/2. So I'm going to substitute 2x squared minus 1. And he's going to be greater than or equal to 1/2. Since they say minus 1, I'm going to say plus 1. And that's going to give me 3/2 over here, if I can write it. And then since they said times 2, I'm going to say divided by 2. X squared is greater than or equal to 3/4. Now, when I take the square root, this is where some people start getting lost. There are 2 square roots, a positive and a negative. If I take the negative square root, I also flip my sign. So that's going to be negative square root of 3 over 2. And when I take the positive square root, I leave the sign alone. So that's going to be a positive square root of 3 over 2. I can take the square root of 4. I can't take the square root of 3, so I just leave him under the radical. So my domain, and this is going to be interesting here in a minute for some of you, is going to be negative infinity up to negative square root of 3 over 2. That covers the x is less than or equal to. But then I also have, and since you can't be in both at the same time, please use union, not intersection. I also have positive square root of 3 over 2 greater than or equal to, so going out to positive infinity. This is the domain of my composition, okay? This is my domain of the composition. Now that I've got the domain, let's go back and look at the composition, then we're going to look at something kind of interesting. So to find f of g of x, says I'm going to plug g of x into f, and so here's f, 2 times, what's in parentheses, 2x squared minus 1, minus 1. So, very quickly again, here's the square root of 2 times whatever x is, and the 2x minus 1 there was my x. So highlighted in yellow, you actually see my function f with g written in the place of x. Okay, so then I'm going to simplify, distribute the 2 through. That gives me 4x squared minus 2 minus 1, all under the radical sign. And then I collect like terms, and I get 4x squared minus 3. I cannot simplify that because of that minus sign. I can't just take the square root of 4x squared. That minus sign will not allow me to do it. So this is going to be my composition, f composed with g of x with the given domain. But watch this. If all of this, substituting g of x in for x and solving for the domain, take a look at this. If I looked at my composition and I said, well, I know that what's under the radical, that radicand has got to stay non-negative, and I solved that. Notice, I should have gone down to here. I end up with the same exact domain. Will it work that way every time? It will every time that g is a polynomial. Anytime I've got all real numbers for g, then yes, I can wait till I get to the end and find the domain of f composed with g and have the correct domain. Now, just because sometimes it really does happen, let's take that same example but turn it around backwards. Instead of doing f composed with g, this time we're going to do g composed with f, which means my restrictions with x having to be greater than or equal to 1/2 comes in right off the top. So only those values that fit x greater than or equal to 1/2, only the answers that we get, those answers are going to be my restricted domain here. Okay? We'll come back to that at the end, but for right now, let's get g composed with f done. So this is g of square root of 2x minus 1. Okay? So g was 2 times x squared, but my x is square root of 2x minus 1 squared minus 1. Well, the square root and the square sort of halfway. You might want to say cancel each other out. So that leaves me with 2x minus 1. And 2 times 2x is 4x. 2 times 1 is 2. And negative 2 minus 1. Look, I end up with 4x minus 3. Now, here's where the problem comes in, and this is why I did not do it initially. If I wait until the end and I have my answer and I want to state the domain now, I would say it's all real numbers, because that's a polynomial function and the domain for polynomial functions are all real numbers. The problem is this results back to here. And so if you tell me I can use a negative, okay, let's say a negative 4, then this becomes the square root of negative 9, which is 3i. You've left the real number system, which we're not allowing. This is why I always look at mine right here at the beginning, especially if the restriction comes in on this guy right here, the guy that's being composed. Okay? So the restriction being there is going to make waiting to the end not feasible. On my domain, I still can only consider numbers that are greater than or equal to 1/2. Okay? Gets a little tricky when there's a restriction on the second stated function. So be sure that you're careful with that.